Okay, so now we are going to get into theoretical probability. Now, theoretical probability is any occurrence, we kind of think about how many outcomes fit our description. Any occurrence from which an outcome is uncertain is called an experiment. Okay, so something that you do is an experiment. Now, the set of all possible outcomes of an experiment, all right, is the sample space of the experiment, usually denoted with a capital S. Okay, and then an event E is a subcollection or subset within the sample space that you're trying to see what's the chance of that thing happening. So an experiment would be something like rolling a die, and a sample space would be all your possible outcomes, 1, 2, 3, 4, 5, 6. And then your event could be something like rolling a 3, an even, less than 2, stuff like that. Okay, those would be events. Now, theoretical probability applies to situations in which the sample space only contains equally likely outcomes. Okay, now something that all your events have equally likely outcomes. Okay, rolling a die. All right, all numbers 1 through 6 have the same chances of being rolled. Flipping a coin, heads or tails. Picking a name out of a hat. Let's say I put all your names in a hat. You all have an equal chance as everyone else in the class of being selected because it's random. Now, all we're going to do, it's very common sense. It sounds like with all these words that it should be harder, but it really isn't. Okay, so let's say a single die is rolled. Find the probability of getting a number less than 5. So this is where I'd use that letter A thing, where A is a number less than 5. Okay, so I want to find the probability of event A happening. Well, I got to look at my sample space, right? The numbers 1 through 6. How many of them are less than 5? 4 of them. Out of how many? 6. So the probability of rolling something less than a 5 is 4 to 6. Or you could simplify it to 2/3. Now what about if instead of one 6-sided die, I give you 2? Alright. What is the probability of getting a sum of 8? So I'm going to make A the sum of 8. Now because we're throwing 2 dice, it's not like a 1 in 6 chance anymore. Okay, we got to think kind of like the counting principle that we talked about in 10.6. And what we're going to do is we're going to think about the first die. We have how many outcomes? 6. And then the second die, there are 6 outcomes. So we're going to multiply, and we have 36 possible outcomes when we roll 2 dice. So that's going to be our denominator when we go to find the probability of A. We know there are 36 total outcomes when I roll 2 dice. Now I got to think they all have an equal chance of happening. But now when I look at the sum, I got to see how many of these add up to 8. So we got to think about the first and second die separately. So what adds up to 8? We can have 2 and 6. And if we could have 2 and 6, we could have 6 and 2 because they're on 2 separate dice. The order does matter. Then we could have 3 and 5, which means we could have 5 and 3. And then we can have 4 and 4. Now we're not going to switch this because if we switch it, it's still the same exact thing. So we have 1, 2, 3, 4, 5 possible outcomes out of 36. When I roll 2 dice, that would add up to 8. Now, I'm moving from dice to cards. Now, a standard deck of 52 cards. Okay, I'm going to go to the side and show you everything about a deck of cards, but we're going to try and find the probability of being dealt a heart. So in this case, I know H is heart. You could just put that. Okay, well, we know there are a total of 52 cards, right? Now I'm going to stop here because we need to figure out how many are hearts. All right, so here's all the information about a deck of cards. Okay, in a deck of cards, if we have 52, that means we don't have the jokers in the deck. Now, each deck of cards has 4 suits. Okay? Now your suits are diamond, heart, club, spades. Alright, those are your 4 different suits. Half the deck is red for diamonds and hearts, the other half is black for clubs and spades. Now each suit has one of each of these 13 cards. So there is an ace of diamonds, a king of diamonds, a queen of diamonds, a jack of diamonds, and 2 through 10 of diamonds. That is true also for hearts, clubs, and spades. Okay, one of each card per suit, meaning that in the whole deck there are 4 aces. Ace of diamonds, ace of hearts, ace of spades, ace of clubs. And same for king, queen, jack, and 2 through 10. So now that we've looked at this, and we kind of have an idea, we broke down a deck of cards. Okay, I always do this because not everyone knows what's in a deck of cards. They didn't grow up playing cards and stuff like that. So just wanted to take the time to do that. So now, to find the probability of heart, we need to know how many cards in our deck are hearts. Well, we know that there are 13 cards per suit, right? And a heart is a suit. So there are 13 out of 52 cards. Now this could also be simplified to a fourth, which means that if I put in a decimal form, it would be exactly 0.25, and if I put it as a percent, it would be 25%. Any of these are acceptable answers, okay? Within your questions that pop up in this video, I'm fine with whatever you put unless I specify, but just know that on MyMathLab, look underneath the little box where it says in blue, or usually it says within the problem, how they want you to write your answer. So just be careful about that. Now, let's look at this, all right? So, Florida's lottery game Lotto is set up so that each player chooses 6 different numbers from 1 to 53. Okay, notice 6 different ones. If the 6 numbers chosen match the 6 numbers drawn randomly, the player wins or shares the top cash prize. As of this writing, the top cash prize, it could be anywhere from $7 to $106.5 million. Nice. With one lotto ticket, so you only bought one ticket, what is the probability of you winning this prize? So we got to think, in order to win, you need to know how many outcomes win. Well, you're picking 6 different numbers, right? And the order doesn't matter. As long as you have those 6 numbers, you're going to win. Okay? So you only have one outcome that's going to win. All right? And you also only bought one ticket, so you only have one in whatever chance. Now, what's the probability of winning this prize? Well, we got to know, well, how many different outcomes are there, right? So we got to think, we're picking out of 53 numbers, we're picking 6 of them at random. Okay, but are we going to do permutation or combination? We got to think, did the order of the numbers make a new outcome? Did you have to get them exactly in the right order, or could it be any order as long as you had the 6 numbers? They didn't say order mattered, so order doesn't matter. Meaning that it is combination. We're going to do NCR. So 53 C6 will tell me how many total outcomes we have for the lotto. How many different types of lotto tickets you could have. So 22,957,480 is what you get here. So out of all those different types of combinations, you only bought one ticket. So your chance of that one actually working is 1 out of that. So you really don't have some good chances of winning this. Now think about things that could help. Something that could help is having the ticket be, maybe instead of picking 6 numbers, you pick 9 numbers. Or instead of there being 53 numbers, maybe there's only 40 numbers to choose from. Okay? Or you buy more than one ticket that has different numbers. All those things will help you have a better or higher chance of winning. Now, the probability of an event not occurring, all right? Something like the probability that it is not going to rain, all right? You could also see it referred to as the complement, all right? So if you want to find the probability of something not happening, it's basically the rest. So if I said the probability that it's going to rain is 10%, if I asked you, all right, knowing that the chance it's going to rain is 10%, what's the chance it won't rain? You're going to quickly say, well, 90%. Duh, it's the rest, okay? So what you're going to do is to find the probability of something not happening, or this C exponent means like complement. That's another way you can see it written. Is just 1 minus the probability of E happening. Remember, 1 is the same as 100%. Okay? So, it's just the rest. Now, for this example, okay? So this pie chart down bottom is showing the world population, okay, out of the 7 billion or 7,000 million people. It's showing how many million people live in each section, content, or region of the world. Okay? So if one person is selected at random, find the probability that the person does not live in Asia. So I want Asia complement, right? Or not Asia. Well, express the probability as a simplified fraction and as a decimal rounded to the nearest thousandth. Okay, so what I'm going to do to figure out probability of not Asia, I need to know, well, how many people live in Asia? So I see Asia is 4,230 million out of the 7,000. So to figure out not Asia, I know, well, out of the 7,000 million, 4,230 live in Asia. So the rest, right? So I'm going to do 7,000 minus 4,230 all over 7,000 to give me that probability. When I subtract, I'm going to get 2,770 over 7,000. Okay, the reason they wrote the 7,000 million instead of 7 billion is because they want everything in the same unit of measurement. Now it says to simplify this fraction, right? So put this in your calculator, do math enter, enter, or math frac enter, and you will get 277 over 700. It unfortunately doesn't simplify anymore. And when you actually divide it and round to the nearest thousandth, meaning 3 decimals, you're going to get 0.396. So that's probability not Asia, or complement, Asia complement.